All right, this is Algebra lesson 3.4, direct variation. Have you ever even heard of that before? Okay, I wouldn't think so. Direct variation. Let's read it over here on page 180. Everybody should be over there on page 180. We're over here on page 180. You're reading with me on the highlighted section, direct variation equations. A direct variation is described by an equation of the form y equals kx. Okay? Where k does not equal 0. The equation y equals kx illustrates a constant rate of change, and k is the constant of variation, also called the constant of proportionality. I'm never going to use that word again, constant of proportionality again, but whatever. Just you've seen that, constant of variation, constant of proportionality, same thing. Here's the deal, just very briefly. The difference between the constant of variation and the slope, you know what the difference is between the constant of variation and slope is? Nothing. They're identical. The difference is you're talking about two different things. Not really. I mean, like, you can just, it's kind of like how I talked to you about, like, y can also be f of x, right? One is you're talking about functions, one is you're talking about an equation, but they're the same. The constant of variation and slope are the same. So it's kind of silly. In the book, a lot of times they'll say, okay, they want you to name the slope and the constant of variation. And the answer is always like 2 and 2, or -4 and 4, or 3 halves and 3 halves, because they're the same thing. Okay, not the point. I'll explain that to you here in a second. But anyway, to find the constant of variation by graphing or by looking at a graph, all you're going to do is the exact same thing you would do for slope, right? Look at the example there on page 180. Example A. It says name the constant of variation for each equation, so A and B. Then it says then find the slope of the line that passes through each pair of points. They're the same. You see what I'm saying? The constant of variation and the slope are the same. So anyway, what is the slope for that first one? If you look at it, what's the rise? As we're going from left to right, what's the rise? It's what? No. As we're going from left to right, what's the rise? It's -4. We're going down 4, right? If we're talking about rise over run, and we go down 4, that's a -4. Does that make sense? From left to right, we're going down 4. Once we're down there, we're running to the right, which is a positive. How far are we running? 1. So then we have -4 over 1. What's the slope? -4. What's the constant of variation? -4. Do you all understand that? The constant of variation and the slope are the same thing. Got it? Okay. What about letter B? Rise over run. What is the slope? Well, you first have to look at that thing and go, okay, going from left to right, what's the rise? What's the rise? 3. Once you get up there, we're running to the right. How many am I running? Is the slope 3 over 6? Yes. Is that what you write down? No. What's the slope? What is the slope? 1/2. What's the constant of variation? So here's the deal. When you see this, y equals kx, when you see that right there, that k is the slope. I need to show you that, okay? Just let me show you. Y equals kx. Let's do okay, whenever we're talking about the constant of variations, okay, whenever I'm going to talk to you about a constant of variation, one of the points is always the origin. That's the difference between slope and constant of variation. Is slope can be anywhere. Slope can be over here. Slope can be here. Slope can be over here, right? if it goes through the origin, all constants of variation go through the origin. It's that simple, okay? They always do. They do have a slope, but they always go through the origin. What's the origin? 0, 0, right? Okay. So, here's the deal. Y equals kx. If I were to tell you to graph this, except that is the, what do they call that? That's the direct variation equation. And I was to give you this, y equals 2x. What is the constant of variation of this? What's the constant of variation? The 2, right? The k is the constant of variation. That's 2. That is the same thing as the slope, okay? Y equals kx. Now, what we can do, though, is just, even with just this, even if we didn't figure out what the y-intercepts are, what the intercepts are, y and the x-intercepts are, you could graph this just by using the slope, just by using the constant, because you need 1 point and the slope to draw the line. Let's draw this line. Here we go. We're right here. Right there. What is 1 point that we know is on this thing? 0, 0. We know that. How do we know that? Because it's a constant of variation. Y equals kx. When you see y equals kx, you know one of the points is 0, 0. So we know that this is one of them. What's the slope again? 2. What does the slope of 2 mean? What is the rise over run? 2 over 1. That means it's going to go up 2 and over 1. There's another point. Once we have how many points can we draw our line? There's our line. There's our graph. Remember, if you have a y equals kx constant of variation equation, one of the points is 0, 0, and then if you know what the slope is, you can just start at 0, 0 and then go up and or down, or what, you know what I'm saying? You can adjust and draw your line. Okay? Now that we've done that, let's see if you guys can do a couple of these. Let's try one right now. Do y equals 2/3 x and do y equals negative 5x. I want you to graph both of those for me. Okay, so here, watch. You're just watching here. All right, we're going to draw our little coordinate plane here. Okay, on this first of all, these are both constant of variation equations, right? Because how do you know if they are or not? Y equals kx. Can it be written y equals kx? There's no extra numbers. There's nothing extra. It's just y equals kx. What 1 point is guaranteed to be involved in y equals kx in the constant variation equation? 0, 0. We know that's one of them. Now, to find the slope, this one, there it is. There's the slope right here. That's the constant of variation. And what is that slope? 2/3. That means it's up 2 and over 3. Right there, right? Up 2 over 3. Agreed? Is that enough points to draw my line? When you're doing this at home, when you're doing this for your homework, have a ruler, have something sharp, have something straight so that you can draw. You don't want to draw it like this. You know what I'm saying? Like, you don't want to do that. That's sloppy. You do want to have a nice straight line. Use a ruler. It takes 2 seconds to just put it on there and draw it nice. Make sense? There's the first one. That's graph. Perfect. I have y equals negative 5x. Is that a constant of variation equation? Yes. What if I said y equals x? Would that be, is y equals x a constant of variation equation? Absolutely. What's the constant? No! No! If it was 0, then it would be y is 0, and there wouldn't be an x there at all. Right? What is the constant? A 1. Right? A 1. So anyway, here's the constant of variation. Negative 5. How do I write that in rise over run? Y equals negative 5 over 1. Could I put it 5 over negative 1? Yes. The difference between negative 5 over 1 and 5 over negative 1 or negative 5 over 1 is they're all the same, right? I'll show you both again just so we can be clear that these two are identical. But okay, negative 5 over 1, which means that the rise is? No! What is the rise here? You guys are going to get killed. If you guys keep doing that, you're going to get killed in your math homework and in your quizzes and your tests. If the rise is negative 5 and you say 5, it's no different than me saying, is the answer yes or no? You saying yes when the answer is no, and you go, oh man, that was close. No, they're opposites, right? What's the rise here, people? Negative 5. We're going down 5 and over 1. Is that 1 positive or negative? It's positive, which is to the right. It's right here. There's our deal. Now, wait a second. What if I had chosen this instead? What would the rise be with this? Up 5. And which way would the run would be 1? Which way? To negative 1, which is to the left 1. Oh, it's still the same line, right? It's still the same line. Agreed? Okay. Good. Okay. I think you have that down now, okay? Now I'm going to show you how to write and solve a direct variation equation. Here's the deal. Here's the deal. Okay. This is what the instructions would say. Okay, it would say, suppose y varies directly as x, and y equals 72 when x equals 8. Okay? So here's the deal. Here's the deal. Okay, before we go on to this, I need to explain something to you. Direct variation means this, okay? Because in about 6 chapters, we're going to start dealing with indirect variation. And so you do need to know the difference. You don't need to know the difference right now, but it will help you if you understand what's going on so that you'll be able to appreciate when we get to indirect and you go, oh, I get the difference. Direct variation means this. You'll notice this. First of all, you always write down the direct variation equation. Why do you write down the direct variation equation? Because the instructions tell you to. Look at it. It says, suppose that y varies directly as x. They've told you that y varies directly as x. They're telling you to use the direct variation equation. Because they're saying, suppose that y varies directly as x. So what is the direct variation equation? Okay. I need you to look at this really quick. Look at the direct variation equation. If y gets bigger, I need you to look at that. If y gets bigger, let's say that y is a 2 for now. Okay, y is 2. And the k is, we'll just leave it as k. We'll say it's whatever. And x is 5. That would be 5k. Agreed. That's how you'd write it. But we're going to leave it like this for now. If 2 became, listen, let's put a line on the equal sign. If I was to multiply 2 by 10, right? If I was going to multiply this side by 10, what would I have to do to the other side? Multiply it by 10. That 5 would get also 10 times bigger. Does that make sense? They're on opposite sides of the equation. And so when y goes up, x has to go up. If I divide y by 2, what am I actually doing with x as well? Dividing it by 2. Whatever I do to y, whatever direction y goes, x is going to do the same, right? They're directly related. When x goes up, y goes up. When y goes up, x goes up. When y goes down, x goes down. They're directly related. Does that make sense? When we start dealing with indirect variation in a few chapters, when x goes up, y goes down, and when x goes down, y goes up. We'll deal with that when we get there, but for right now, you just need to know that these are direct variation. They each will go up, or they'll each go down. Okay, so here's the deal. This is what you're supposed to do with this. They've told you, so right here, and it's so important you get these words because on your test, I give these words. I say, suppose that y varies directly with x. As soon as you see that, what do you know you're going to need to use? The direct variation equation, which is y equals kx. You just need to know that. I'm not going to, if you come back to me and say, Mr. Young, what do I do with this on the test? I'll be like, yeah, I can't help you. You've got to understand the directions because I'm telling you now that you need to know this verbiage so that you know what to do with it on your test. Okay? So we are using the direct variation equation, and what you do is you plug in what you know. Okay? You plug in what you know. What do I know? That y is 72 when x is 8. So plug that in. Plug it in. 72 equals k times 8. Do you agree? I've plugged it in. Agreed? Solve for k. We're now going to find the constant. Divide by 8, divide by 8. K equals what? What does k equal? What is 72 divided by 8? You better all know that. 9. So listen, k equals 9. We also decided that what is k? What's another name for k? Slope, right? So the slope of this line right here, look, here's our direct variation equation, right? There it is, right? We now know that k equals 9. So we could go y equals 9k, and that's what you're going to do. You're going to go now y equals 9k. You write that down. This is our direct variation equation now. What they may do is this. Look at the letter B for that sample on page 181. It says use the direct variation equation that you just found to find what x is when y is 63. So here's this. You have to understand this. So hold on. Let's back up a little bit. Back up. Hold on. Beep, 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 beep. Let's back up. Are you listening? What I've done here is this. I'm going to erase some of these things so that I have some room. What I've done here is this. We know that whatever we're doing here, we're dealing with the direct variation equation. Yes? Okay. We also know that now that we're dealing with the direct variation equation, what is going to be true about our graph? What's going to be true about it? It's going to go through the origin, right? We know it's going to go through the origin. So here's our little graph, right? There's our graph. We know it's going to go through the origin. This is one of the points. What's another point that we know? Here it is right here. What's another point that we know? 8 and 72. We know that 8 and 72 is another one of the points. That means that when x is 8, which is like over here, that where's y? Way up there at 72. Doesn't matter. We just need to be able to visualize this. That's another point. Agreed? Using this here, we know that there's x is 8, y is 72 way up there. So we know the slope is going to look something like that. Do you agree with me? Do you understand what I'm saying? Okay. What they're now asking you for is this. They said that use that direct variation equation to find out what is x when y is 63. Oh my goodness gracious, do you really want to graph this? I mean, like, when y is 63, that means that when it's way up there, what is it going to be when it's, what is x going to be? So here's the deal. We use do we really even know, when we just have the point 872, we don't really know what the slope is. That's why we created our direct variation equation. What does the slope end up being? 9. That means that we know that, what is another one of the points on here for sure? It's 1, 9. Right here. We know that that's another one of the points. Does that make sense? And this line's going to keep on going up. What they're saying is what is x going to be when y is 63? So we now know the slope is 9. We have our direct variation equation here. Let's use it to figure out what x is going to be. Here's the deal. What are we going to plug in? Y is 63. 63 equals 9. Did I put k here? That's supposed to be an x. Right? Equals 9x. Divide by 9, divide by 9. X equals 7. When y is 63, x is 7. Does that make sense? I'm going to give you guys one to try right now. I'm not going to write all these words out. Here's the deal. Suppose that y varies directly as x. Okay? That's how it starts. So as soon as you see that, what should you write down on your paper? For real. If you're reading on your test, suppose y varies directly as x, you write down y equals kx. Just write it down so you know that that's what you're supposed to use. So suppose that y varies directly as x. Oh, y equals kx. Okay. Then it says, and y equals 98 when x equals 14. Then it says, write a direct variation equation. Okay, that's one part. That's one part. And then the next one is find y when x equals -4. Okay? That's the two things you need to do. Try and figure it out. I forgot to record that last part. That's really silly. But here it is. Okay? Remember, just really quick, a recap for those of you that didn't, because I didn't do this. Remember, you start out with y equals kx. Then you have to figure out, you have to rewrite y equals kx, except you got to know what k is. To do that, you use the information they gave you. So you would go 98 equals k times 14. Solve for k. Divide by 14, divide by 14. K equals 7. Rewrite it now, y equals 7x. And then you plug in what you know and to figure out what you don't know. Okay? All right. I think you guys are ready to do your homework here. We'll see. I don't give you a ton, but we'll see. I don't remember. (10 to 27) even. Yeah, that's easy. Okay, so page 183 to 184, 10 through 27 even. You will need graph paper to solve 16 through 23. Okay? All right.